Welcome again to Astronomy Daily. It's Steve here with another episode. It's the 5th of August 2024.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
And on today's episode, we'll be talking about Northrop Grumman launching a mission to the ISS. We'll be talking about my favourite little rock, Dimorphos. Hallie's going to be talking about Hercules, which has a very weird rotation. And she's also going to be talking to you about the sky watching highlights for August. That's all really good. And speaking of the girl of the moment, would you welcome Hallie? How are you going, Hallie?
Doing just great, thank you, my human. I heard it was your turn for a holiday this week.
That's right. I took a couple of days for a bit of rest and recuperation, Hallie.
And how are you feeling now?
About the same, Hallie.
Do you think you need a longer holiday?
Yeah, probably. I think we all need a longer holiday. And I think I'll coin a phrase and call it Boeing syndrome.
What's that?
Well, that's when you only planned for 8 days off and you end up taking 50.
Oh, I get it.
I wonder if the astronauts feel the same way.
But it's not really their choice.
And it's definitely not a holiday for them anyway.
I guess not.
And hey, Hallie, something else I saw yesterday that really shocked me.
What was it?
It was a survey, and the results showed that 94% of all those surveyed didn't know that the lights in the sky were stars like our sun.
Wow, that's a bit disappointing to hear.
I know, but I had to read it a couple of times to really get my head around it. But before we get all out of shape about it, I have no idea how big the sample size was, because it was an open survey on a social media platform and they didn't release comprehensive results, just the percentage.
Which is a bit sensationalist, really.
Well, yes, it is.
And here you are giving it a boost.
Yeah, guilty as charged, but it still doesn't change the inputs. There are still people out there with the sum total of human knowledge at their fingertips who simply choose not to discover anything, and I find that quite amazing.
Well, dear listeners, aren't we glad we have inquiring minds?
And that is where it starts, yes. And speaking of starting, I think it's your turn, Hallie.
Okay. Here we go. Here are some of August's skywatching highlights for all you stargazers. We can look forward to Mars and Jupiter having a super close meetup, and the conditions look good for the Perseid meteors, and also how to observe a stellar nursery, the Lagoon Nebula. Firstly, on August 4th, we will have a new moon. Then on August 11th, the Perseid meteor shower peaks overnight tonight. Provided you have clear skies, viewing conditions will be favorable this year, as the moon sets by around 11:30 p.m. local time. Meteor activity picks up from then until dawn. On August 14th, planets Jupiter and Mars have an extremely close pair-up called a conjunction this morning. They'll appear just a third of a degree apart, which is less than the width of the full moon. You will find them in the eastern sky in a couple of hours before sunrise. August 19th gives us another full moon before August 20th sees the moon chasing Saturn across the sky tonight. The pair rise in the east shortly after dark and trek toward the west together until dawn. On August 27th in the morning, the crescent moon joins Mars and Jupiter to form a captivating trio. Look for them in the east in the hour or so before sunrise. And all month, you can use binoculars or a telescope to observe the Lagoon Nebula all month in the first few hours after dark. It's located in the constellation Sagittarius near the star pattern known as the Teapot. Similar in size and brightness to the Orion Nebula, it's a cauldron of star formation located about 4,000 light-years away. The Sun rotates the fastest at the equator, and the rotation rate slows down at higher latitudes, becoming the slowest in the polar regions. But a nearby Sun-like star V889 Hercules, some 115 light-years away in the constellation of Hercules, rotates the fastest at a latitude of about 40 degrees, while both the equator and polar regions rotate more slowly. A similar rotational profile has not been observed for any other star. The result is stunning because stellar rotation has been considered a well-understood fundamental physical parameter, but such a rotational profile has not been predicted even in computer simulations. We applied a newly developed statistical technique to the data of a familiar star that has been studied in the University of Helsinki for years. We did not expect to see such anomalies in stellar rotation. The anomalies in the rotational profile of V889 Hercules indicate that our understanding of stellar dynamics and magnetic dynamos is insufficient, explains researcher Mikko Tuomi, who coordinated the research. The target star V889 Hercules is much like a young sun, telling a story about the history and evolution of the Sun. Twomey emphasizes that it is crucial to understand stellar astrophysics in order to, for instance, predict activity-induced phenomena on the solar surface, such as spots and eruptions. Stars are spherical structures where matter is in the state of plasma, consisting of charged particles. They are dynamic objects that hang in a balance between the pressure generated in nuclear reactions in their cores and their own gravity. They have no solid surfaces, unlike many planets. The stellar rotation is not constant for all latitudes, an effect known as differential rotation. It is caused by the fact that hot plasma rises to the star's surface via a phenomenon called convection, which in turn has an effect on the local rotation rate. This is because angular momentum must be conserved and the convection occurs perpendicular to the rotational axis near the equator, whereas it is parallel to the axis near the poles. And right in your backyard, Steve, Rocket Lab has launched its 51st Electron rocket, deploying a single satellite into low Earth orbit for Synspective, a Japanese Earth imaging company. The mission, named OWL for one for owl, in reference to Synspective's Strix satellites, which are named after the genus of owls, lifted off at 4:39 a.m. August 3, NZT, 1639 Universal Time Coordinated, August 2, from Launch Complex 1, Rocket Lab's private orbital launch site on New Zealand's Mahia Peninsula. This launch deployed the 5th Strix SAR imaging satellite for Synspective into low Earth orbit. In addition to the launch service, Rocket Lab provided a custom electron fairing to encapsulate the Strix satellite and performed an advanced mid-mission maneuver with Electron's kick stage to shield the satellite from the sun and reduce radiation exposure on its way to orbit. Rocket Lab has been the sole launch provider for Synspective's constellation to date. This mission marked the 5th of 16 launches booked on Electron for Synspective and the second launch for the Japanese company this year, following the all-night-long mission in March 2024. Recently, Synspective booked 10 dedicated Electron launches as part of a new multi-launch agreement announced in June 2024, with launches in that deal set to take place from 2025 to 2027. Rocket Lab founder and CEO Sir Peter Beck stated, "It's wonderful to have launched our second mission for Synspective in 5 months as we continue our long-standing launch partnership. Electron is the ideal rocket for providing flexible, tailored, and direct access to orbit for constellation builders like Synspective, and I'm proud of the team for delivering this latest mission success." The launch window for Rocket Lab's next Electron mission will be announced in the coming days. And that's it for me. Back to you in the real world.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X, or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space science, and astronomy.
Now off to the surface of Dimorphos again. This is one of my favourite little rocks in the solar system. When NASA's DART mission intentionally slammed into Dimorphos in September 2022, the orbit of the moonlet was altered. Now, we've covered this several times on Astronomy Daily, and those of you who listen regularly will know how closely we've been following this story. Researchers have studied the photos and data taken by DART before its impact, learning more about the geology of the Didymus Dimorphos system, and they've now estimated the surface age of both the asteroid and its moon. And the asteroid Didymus has a surface age of 12.5 million years, while the moon Dimorphos is only 300,000 years old. What that you say? Those numbers don't quite add up. Additionally, the DART researchers concluded that both Didymus and Dimorphos are rubble piles, with Dimorphos likely inheriting its boulders from Didymus. It's a pile of gravel and boulders and some sand and dust, held together by its own gravity, and really not much else, said Andy Rivkin, DART investigation team co-lead at Johns Hopkins Applied Physics Lab on Blue Sky. There's really no cohesion between different pieces of gravel or rocks on Dimorphos. That's a really interesting concept, isn't it? It's just a pile of gravel. That makeup explains why DART's impact made such a surprising change to Dimorphos' orbital period, decreasing it by about 34 minutes. A collection of boulders is easier to shift than a solid object. Several DART researchers published 5 papers in Nature Communications looking at the geology and geophysics of Didymus and Dimorphos as seen by DART. These findings give us new insights into the ways that asteroids can change over time, said Thomas Statler, lead scientist for Solar Systems Small Bodies at NASA headquarters in Washington. In a NASA press release, this is important not just for understanding the near-Earth objects that are the focus of planetary defense, but also for our ability to read the history of our solar system from these remnants of planet formation. This is just part of the wealth of new knowledge that we've gained from DART. In the geology and evolution of the near-Earth binary asteroid system Didymus, Oliver Bartone, Ronald Louis Ballouz of APL and their team were able to determine the disparate ages of Didymus and Dimorphos. They also found that both objects have weak surface characteristics, which are very likely contributed to DART's significant impact on the moonlet's orbit. The images and data that DART collected at the Didymus system provided a unique opportunity for a close-up geological look at a near-Earth asteroid binary system, said Barnard in a press release from APL. From these images alone, we were able to infer a great deal of information on geophysical properties of both Didymus and Dimorphos and expand our understanding of the formation of these two asteroids. We also better understand why DART was so effective in moving Dimorphos. Images captured by DART and its CubeSat companion showed Dimorphos' topography covered with boulders of various sizes. While the larger asteroid Didymus was smoother at lower elevations, though rocky at higher elevations. It also had more craters than Dimorphos. The authors inferred that Dimorphos had likely spun off from Didymus in a larger mass shedding event. This was confirmed in another paper, Evidence for Multi-Fragmentation and Mass Shedding of Boulders on Rubble-Piled Binary Asteroid System Didymus. Maurizio Pagiola of the National Institute of Astrophysics in Rome and team show how both Didymus and Dimorphos are mainly comprised of a collection of boulders. This team concluded that the formation of Dimorphos likely came as Didymus shed material, creating a new asteroid moonlet. The size-frequency distribution of boulders larger than 5 metres on Dimorphos and larger than 22.8 metres on Didymus confirms that both asteroids are piles of fragments produced in the catastrophic destruction of their progenitors, the team wrote. This finding supports the hypothesis that some asteroid binary systems form through the spin-up and mass shedding of a fraction of the primary asteroid. In another paper, fast boulder fracturing by thermal fatigue detected on stony asteroids, Alice Lucetti, also of INAF, and colleagues found that the size and distribution of boulders on Dimorphos is consistent with thermal fatigue, which is the gradual weakening and cracking of material caused by heat. This could rapidly break up boulders on the surface of Dimorphos, generating surface lines and altering the physical characteristics of this type of asteroid more quickly than previously thought. The DART mission was likely the first observation of such a phenomenon on this type of asteroid. Thermal fatigue could also have been a bearing on what happens if this type of asteroid would need to be deflected for planetary defense. The presence of boulder fields affected by thermal fracturing on near-Earth asteroid surfaces may contribute to an enhancement in the ejected mass and momentum from kinetic impactors when deflecting asteroids, the authors wrote. And finally, mechanical properties of rubble pile asteroids through surface boulder morphological analysis by Collis Robin, also of ISAE, and co-authors analysed the surface boulders on Dimorphos, comparing them with those on other rubble pile asteroids including Itokawa, Raiguru and Bennu. The researchers found striking similarities, the boulders on all 4 asteroids, suggesting they all formed and evolved in a similar fashion and were also changed by impacts. This data too informs future planetary defence missions or attempts at impact emissions. Planetary defence efforts rely on estimates of the mechanical properties of asteroids, which are difficult to constrain accurately from Earth, the team wrote. The mechanical properties of asteroid material are also important in the interpretation of the DART impact. All the DART researchers team will continue to observe and study DART's impact. Additionally, another spacecraft will launch in 2024 to study Dimorphos even closer. The European Space Agency's Hera mission should arrive at Didymus and Dimorphos in December 2026. Hera will undertake a detailed study of Dimorphos to understand more deeply how the impact has affected it.
You're listening to Astronomy Daily, the podcast, with your host, Steve Dunkley.
Now, on Sunday, SpaceX successfully launched a resupply mission for the International Space Station after it was postponed on Saturday because of unfavourable weather. The space exploration company used a Falcon 9 rocket to launch the Cygnus spacecraft made by Northrop Grumman, best known as a defence contractor. Northrop Grumman changed its launch vehicle for Cygnus missions from its own Antares 230 Plus rocket to SpaceX's Falcon 9 rocket after the war in Ukraine ended engine and booster production for the Antares program. On board are tests of water recovery technology and a process to produce stem cells in microgravity, studies of the effects of spaceflight on microorganism DNA and liver tissue growth, and some live science demonstrations for students, NASA said in a statement. Shortly before the launch, SpaceX said that the weather was only 35% favourable for liftoff. Yet the rocket took off from Space Launch Complex 40 at the Cape Canaveral Space Force Station in Florida around 11:02 a.m. local time. About 15 minutes later, the Cygnus spacecraft successfully separated to make its way toward the ISS. Next up is a solar array deployment expected in about 3 hours. The next step was the solar array deployment. The solar arrays help power the spacecraft for its journey to the space station, said a spokesman. The Falcon 9 first stage returned to landing zone 1 at Canaveral Space Force Station. This was the 10th flight of the first stage booster supporting this mission, which previously launched AX-2, Euclid, AX-3, CRS-30, SES Astra, 1P and 4 Starlink missions. That's quite a collection. As for the Cygnus spacecraft, once the cargo haul is unloaded by the ISS crew, it will continue to be used as an extended science lab space for the months it remains docked to the station. And I wonder if you're thinking what I'm thinking, could it be used as a rescue craft for the stranded astronauts? Everybody's thinking that. And there it is, another episode done and dusted. Thank you so much for staying with us, and we'd love to see you all again next week. Right, Hallie?
Sure, Steve. And don't forget Anna and Charlie with their shows during the week and register for the newsletter just like Steve said.
Yes, that's right. Anna and Charlie, our other AI presenters, will be carrying you through the week. Don't forget their shows. It's always good stuff. And the Astronomy Daily newsletter has 1,000 times more, well, not 1,000 times, but a whole lot more in it. So, yes, get your fill every week in your email. It's fantastic. All right. So that's all from me. Goodbye, everybody. I'll see you next week. See you, Hallie.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.